Welcome to the tutorial on interfacing an external slave device with the PGY i3C EXPD. Taking a look at the i3C unit, on the side we can see 6 LEDs. Each LED corresponds to a different status, and the user can easily understand the state of the i3C unit by taking a look at the LEDs. When the device is powered on, the LED 1 will glow indicating that the unit is in the power on state. Next, the LED 5 will glow for the first 4 to 5 seconds indicating that the unit is booting. This LED turns off once the unit is booted, and after this, the user can establish connection with the i3C unit. Please note that it is necessary for the i3C unit to boot up to ensure successful connection establishment. Opening the software, the user has to establish a connection with the hardware unit by clicking on Check Hardware Connection. Next, we add one i3C master. So the node type is master, the interface is internal as we are configuring the internal master. Termination helps the user to turn the programmable pull-up resistors of 2.2 kilo-ohm on or off, and the voltage level is set according to the voltage level that the slave device operates at. After all these parameters are set, then click on Add Device. Taking back a look onto the i3C unit, the LED 4, also known as the heartbeat LED, will blink every second indicating that the i3C unit is ready to capture data. When the user configures an internal master, LED 3 will glow indicating that the internal master has been configured. Next, we configure an external i3C slave. For this, the node type will be i3C slave, interface type will be external, termination is turned on, and the static address corresponds to the unique static address of the slave device. This field can be left empty for an i3C slave, as an i3C slave requires a dynamically assigned address by the master. Lastly, the voltage level is set accordingly. Next, the user has to configure the BCR, DCR, and PID values. It is not mandatory to configure these values, but if the user wishes to communicate with the slave device using the parameter node, these values have to be entered into the software. Here, we set the values according to the slave device. After successfully entering all the values, we close the pop-up and click on Add Device. The user can verify what devices are currently present on the bus using the i3C bus network as shown. Here, we see one main master and one external i3C slave device. The user can click on either to view the information that had been configured previously. After verifying, the user must click on Start Capture, which will turn on the protocol analyzer to monitor for any traffic on the i3C bus. The start capture must be done before sending any commands from the master to slave. Finally, when the user clicks on Start Capture or Acquire, the LED 4, that is, the heartbeat LED, blinks faster indicating that the protocol analyzer has started capturing the data. Next, the user has to assign a dynamic address to the slave. Here we will be using the enter DAA command for this purpose. Once we click on Run, you can see that the dynamic address has been assigned to the slave, and the same information is updated in the decoded result view. In some cases, the user does not know the BCR, DCR, and PID values of their slave device. In such cases, if the slave device supports the enter DAA command, the user can just send a broadcast enter DAA command from the i3C master and get the information of PID, BCR, and DCR values of the corresponding slave device in the selected frame view. After noting down the values, the user can then go to the i3C bus network and click the edit icon and update the values. After this is done, we can communicate with the i3C slave using the parameter node. In this video, as an example, we will showcase a common use case scenario that involves reading from a particular register address and writing some data to that particular register address. For this, we load an example script as shown. Taking a closer look, using this script the user writes the data 9 to the register address 50, and then reads back the same data from the register address 50 using the parameter subaddress. The user can specify how many bytes of data is to be read accordingly using the parameter data count. Here, the parameter node corresponds to the node ID value of the i3C slave device. The PGY i3C EXPD keeps a track of the node value internally, due to which the user does not have to specify the dynamic address of the slave every time. The user can communicate to the slave device using the node parameter if the BCR, DCR, and PID values are specified as explained earlier. An alternative to the parameter node is to specify the slave's dynamic address. Another use case scenario is when the user would just like to read some data from a particular register address. To do this, the user has to just send the read command from the master. For example, if the user wishes to read data from registered address 75 of the slave device, we specify the data count equal to 1 in the read command. Running the script, we can see the slave address 8 followed by the memory location 50 and the data is 9. This is followed by the write command to the sub address 50 and the read command. As seen in the plot view, the master reads the data 9 which was written to the memory location 50. Similarly, if the user would just like to read any data from a particular memory location, we specify the read command. In this case, we are expecting the data 42 from the memory location 75 which can be seen in the selected frame view as well as the plot view. So this is all for today's video. Thank you.